Welcome to Flutter for React Native developers. So if you've been a React Native developer like me, you know learning a new framework like Flutter can be slightly daunting to start with. In this course, we'll utilize your existing React Native knowledge to get you up and running in Flutter. React Native is only going to be used as a reference point. This course is going to be a complete Flutter course from scratch. So you will not see any React Native code, but in the starting chapters, I will be referring to React Native often to help you compare what one particular thing in React Native would mean in Flutter. So let's see what you're going to learn. We'll be building one complete app which is going to work on iOS and Android. It's going to be the iOS Reminders app. We'll start with the basics of Flutter and build out the UI of the app. We'll then go ahead and add navigation to the app. And once we have that in place, we'll start making the app stateful. We'll then add authentication to log in the user. And once we have the users logged in, we can start adding the users' reminders to the database. We'll use the Firebase Firestore database for that. Once we have everything set up, we'll handle the app-wide state using the provider package that's available in Flutter. So let's just have a look at our completed app. We have a sign-in screen. We have a sign-up screen where the user can sign in or sign up. In the sign-in screen, the user can sign in. Once the user signs in, the user is taken to the home screen. There we can see we have 4 categories. We can edit those categories by showing or hiding them. We can also change the theme of our app by making it a light theme or a dark theme. The user will be able to go ahead and add a list. Select an icon. Once the list is added, the user will be able to add reminders to that list. Select a list to which it wants to add it. Select the category for the particular reminder. Select a date and select a time. Once the reminder is added, the user can either view the reminder by the category or by going into the list that the reminder was added to. To mark a reminder is completed, the user can swipe to delete the reminder. We can also go ahead and delete the list. In just a couple of hours, we're going to build out this complete app from scratch, and I can't wait for you guys to join me on that journey. So what is Flutter? Flutter is a framework like React Native to create mobile applications. The surprising thing is that it actually takes inspiration from React. The central idea is that the UI is built out of widgets. If you've used React or React Native, you're familiar with components. Instead of components, here we have widgets. Just like components, widgets describe what their view should look like given their current config and state. It's also declarative in nature, that is, when state changes, the UI rebuilds from scratch to display the new state. Just like React Native, Flutter also uses reactive style views. The state updates and the view updates. The main difference comes in how the code is compiled down to the native code. React Native transpiles to native widgets using a JavaScript bridge, whereas Flutter compiles all the way to native code. There is no JavaScript bridge. Flutter controls each pixel on the screen. So instead of using the existing native components, Flutter actually creates the component from scratch. Thereby, Flutter does have a performance benefit as it does not have to cross any bridge. Flutter uses the Dart programming language. It's an object-oriented language which we learn as we go about building our Flutter app. So since we want to get up and running with Flutter without any hiccups, we're going to be using the recommended editor, which is Android Studio for creating Flutter apps. Once you have Android Studio opened up, click on Create New Flutter Project. Here select Flutter Application. Let's name our app iOS Reminders. Make sure that the Flutter SDK path points to where you installed Flutter, and then set the project location as per your liking. We'll leave the description as it is and click on Next. On the package name page, again we'll just leave it as it is and click Finish. So here Android Studio has created our Flutter project for us. Let's first look at the project structure. Here you have your project name, which is iOS Reminders. Let's open that up. Inside this, we have a set of files and folders which have a dot in front of them. These are basically hidden files and are files that are needed for configuration for the IDE. We won't be touching any of these files apart from probably the git ignore file when you want to ignore any packages from your version control. The files of importance to us are going to be the Android folder, which will have the native Android code, the iOS folder, which will have the native iOS code, and then we have the lib folder, which is where we're going to be writing the code for our Flutter application. This basically has a main.dart file, which is the entry point for your app. It's similar to the app.js and index.js files in React Native. Next, we have this test folder, where we can write tests for our project, but since we're not going to be writing any tests as of now, we can go ahead and just delete this folder. Lastly, we have the pubspec.yaml file, which is basically the file that holds all our packages. It uses the pub package manager for Flutter to install and update our packages. This is exactly similar to our package.json file that we use in React Native. It's just that here it uses YAML as its preferred language, and there are just a few syntax differences. So let's head over to the main.dart file, and what we're going to do first is get rid of everything that's here. So I'm going to select everything and delete it out, and then we're going to write our first function. It's going to be a main function, which is basically required for every Flutter project. It's the entry point of your app. In Dart, every function must specify the return type. In this main function, we won't be returning anything. That's why we pass in this void return type. This is the only return type which is not mandatory and can be omitted, and it'll still work. But just so that we get used to it, we're going to let void remain here. Inside this, we need to actually run a specialized function called runApp, and inside that, you have to pass in your app. So we're going to pass in the app called app and close that out with a semicolon, which is mandatory in Dart. As you can see, we're getting an error for runApp, and that's because runApp isn't defined. In order to get access to runApp, we're going to import in a file called material.dart. It's a file that builds on the foundation classes available in Flutter and gives you the material design components ready for you to use. Unlike React Native, Flutter does not use the native components, so even if we use the material design components to create our app, we can customize them to suit our iOS needs. We also have a similar file called Cupertino, which basically gives you access to all the iOS design type widgets. Again, since Flutter is creating all these widgets from scratch, they can be customized to suit your Android needs as well. So for now, we're just going to get rid of the Cupertino class and just use the material.dart, and we'll talk about these more in the future videos. Now, as you can see, our app class does not exist. So let's go ahead and create our app class. So the app class is going to be a stateless widget. If you type in STLESS, it should give you your stateless widget. Let's name that app. And as you can see, class app extends this stateless widget. We'll talk more about this shortly. All it does is contain a build method, which is similar to your render method in React Native. And in that, it returns this empty container widget. Let's save that out. Here, let's open up our iOS simulator. And then let's run our app by clicking this play button on top. Here you'll get a console, which will tell you that it's building out your main.dart file on your simulator that you've opened up. So as you can see here, our app is opened up and we've got a black screen as expected due to this container widget. So if you have a look here, we have an app class which is inside a runApp method, which we already know is a specialized method provided to us by Flutter. Then our app class itself is a stateless widget, which has a build method inside which we've passed in a container widget. Everything in Flutter is a widget, including this app class that we've created here. The context that we have here is basically just the location of this particular widget in the complete app. We'll be covering this further when we build out our app. But what is this stateless widget? So if you've used React Native, you know that we had functional components and we had class-based components. Before we had access to hooks, we would only use functional components when we had no state in our class. Similarly here, in Flutter, if we want to use a component or a widget which does not have any state of its own, then we use a stateless widget. You cannot pass in any state inside it. One last thing I want to cover in this video is the formatting of your Dart code. Here, as you can see, we have a couple of braces on the same line. If you want to move these out into separate lines, we can just pass in a comma here after the closing brace of the app class and then hit save, and we'll notice that the Dart formatter will format our code nicely for us. So we've gone ahead and created our first app, which has an app widget within which we have a container widget. The container widget is similar to a view which has a flex of 1 in React Native. So it basically takes up the complete space and you can pass in components or widgets inside it. Now we know that any widget that we add inside the container widget is going to be a child of this widget. So in Flutter, the way you actually add another widget inside a widget is by using the child property. So we'll say child. Now let's go ahead and try and add a text inside this. Like we know in Flutter, everything is a widget, so we can try and look for the text widget. So I'm going to say text, and here we find this text widget. Let's select that, and inside that, let's pass in the text we want. So I'm just going to say hello. Let's save that, and unfortunately we're getting an error here. It tells us that no directionality widget was found. That is, it does not know whether it wants to display the text from left to right or right to left. So in order to do that, we need to add the directionality widget. On Mac, just press Option Enter on the text widget and you'll get this nice helper open up. It provides you with these common use cases of wrapping this widget with another widget. In our case, we want a widget that's not here, so let's select Wrap with Widget and pass in directionality. Once we add directionality, we get this squiggly line under it. Let's just highlight this and it'll tell us that a parameter text direction is required. Add required argument text direction. So let's select this. So we get this text direction parameter. I'm just going to put a comma here to format this. To add the text direction, we'll look for text direction, which is an enum value, put in a dot and then select the value we want. We want left to right. Let's save that and we get this hello on top. Now we want to move this here to the center. Normally we would use align item center or justify content center in React Native to move it to the center. Like you must have probably guessed, here there must be a widget for it. So let's try and wrap directionality with a widget that looks like it's going to put it to the center. And here we already have a wrap with center. Let's just wrap it, save that out, and we get hello in the center. But this looks like a lot of work to just display a text. If this is how hard it is to put in text, how hard would it be to actually create your app? So there is a way to get a set of styles which will handle these common problems for you. Here on top, remember we had imported this material.dart file. Basically, this will take care of our normal styling issues and let us focus on the project. So what we're going to do is, we're going to wrap this container into a material app. So we'll say wrap with widget. We'll pass in material app. The material app does not take a child property, but in fact, it takes a home property. So we pass in home and we pass in our container. We get our hello again, but the styling is messed up. So in your Flutter project, you need to have only one material app, which is at the root of your application. But every screen or page that you have needs to have something known as a scaffold. So let's wrap the container in our scaffold widget. So we'll say scaffold. And again, the scaffold doesn't take a child, but in fact, it takes a body property. If we save that, you notice now we have a white background with a black text, which is similar to the light theme that we're familiar with. If we just highlight scaffold, it creates a visual scaffold for material design widgets. So every page should have a scaffold, and inside that, we should put in whatever we want to display. You'll see what else we can do with this scaffold as we build out our app. So we've spoken about the structure of the main.dart file and also its main components. If you're new to Dart and you're new to object-oriented programming in general, you might be wondering what this override method is. So basically, add override is just an annotation that tells you that build, which is this method here, is a method that exists in the parent class or superclass, which is the stateless widget in this case. In our particular app class, we are overriding that parent method and writing our own code inside it. It's important to note here that the override method in Dart is optional and can be omitted. However, it is good practice to improve readability to have the override method here. Another small thing that I'd like to cover is this build context here. Basically, like I said, the build context is the location of the particular widget in the app. So basically all your widgets together create a widget tree. You have your app class. Inside that you have your material app widget. Then you have your scaffold widget, container widget, and then the center widget. Each of these widgets have their own build context. That's how Flutter gets to know where the particular center widget exists in the widget tree, and the build context can be used in various ways to update your UI. Last video, we added this scaffold widget inside our material app. Let's have a look at what this scaffold widget gives us. If we just command click on the scaffold widget, we can see the properties that are there in it. As we can see, we're already using the body property, which gives us access to all the content that we're displaying on screen. Along with that, we already have access to a default app bar. We can get a floating action button. We can also add a draw, a bottom navigator, a bottom sheet, and several other things. So that's why the scaffold widget makes it quite easy for us to add the common things that we normally need in our app. Let's have a look at how we can add an app bar. So here inside scaffold, we need to pass in the app bar property. As you know, the app bar itself is going to be a widget since everything in Flutter is a widget. So we're going to look for app bar with a capital A. There we can see app bar. You have to open up rounded brackets and pass in properties for the app bar. If we command click on app bar, we'll see what all properties it can take. The one we're concerned with is title for now. So let's first pass in title and say first Flutter app. As you can see, we got an error here because nothing can be passed in as a string. We need to make sure that we convert this to a text widget. Android Studio knows that we make this error fairly often, and it already gives you a recommendation which says wrap in a text widget. Let's save that, and there we have our header. It's already using the material design components, and that's why we get this light blue color. Soon we'll see how we can also theme our app in order to change this color app-wide. Similarly, we can easily add a floating action button by using the floating action button prop that's available in the scaffold. Then we can look for floating action button, open up the rounded brackets, and it'll show you that these are the properties available, and since it has a squiggly line under it, that means it needs a required argument, which is on pressed in this case. Let's pass that in. There we get a floating action button. Inside that, we can just pass in a child. We can make this child a text for now again and just say add. And there we see we get a floating action button right out of the box. So as you can see, there are a lot of advantages of using the scaffold along with your material app. It greatly reduces your development time as it gives you a lot of features right out of the box. So now that you've warmed up to Flutter, let's finally start building out our iOS Reminders app. It's this app here on our right. It's pretty similar to the actual iOS Reminders app. It has one home screen here, which has a summary of your reminders. You can add a new reminder that'll take you to this modal screen where you can enter the details of the reminder. You can also add a new list, which will add the list to your My List section. You can swipe the list to delete it, or you can click this edit button, which will modify your view to allow you to reorder your lists, show and hide lists, and also delete out lists. As we go along building out this iOS Reminders app, we'll be learning quite a few new things in Flutter. And as always, the best way to learn anything new is to actually try and build something out with it. So we're back in the app we had started with, but we're going to delete everything out from here. Let's get rid of this home property. And we have an empty material app. The first thing that we're going to create in our app is going to be our Navigator. It's almost impossible to have any mobile app in which you don't have to navigate to another screen. So it makes sense to actually start with the Navigator. The good thing is that Flutter has a built-in navigation system. You don't need to import in any navigators or add any external dependencies. The material app itself has its own navigator, and it's easy enough to set up your first initial route. So if you click through into the material app, you'll notice that it has these properties for routes. We have our initial route, then we have many other properties. So let's start with initial route. We'll pass in initial route, and we'll just pass in a /. Next, we can go ahead and define our routes. So we'll say routes, which takes an object. Let's open that up with two curly braces. We pass in the route name, which is a / in this case, And then just like JavaScript, you can use a fat arrow function to point to your screen name. So we'll say home screen, and here it's mandatory for us to pass down the context to our home screen. Next, we need to go ahead and create this home screen. So in our lib folder, we'll create a new package, call that screens. Inside screens, we'll create a new Dart file and name that home screen. The naming of files in Dart uses an underscore with no capital letters. Here we'll create our stateless widget and call that home screen. In order to get access to stateless widget, we're going to import in material.dart. Let's save that. Come back to your main screen, and here let's import in home screen. Let's save that out and let's just reload our app, and there we see we're getting our home screen, which is a black screen. So earlier when we were not using our Navigator, we needed to pass in the home property to our material widget. But now since we're using the initial route, we don't need to pass in the home property. Now let's start setting up the UI of our home screen. So here in our home screen, we right now have a container widget. Let's go ahead and wrap this in a scaffold. Like we know, every page should have a scaffold. So here we'll say scaffold, and instead of child, we'll pass in body. So there we get the light theme. We'll put in a comma to format our code. In our scaffold, the first thing we want is an app bar. So here we'll pass in app bar, and then again we'll say app bar, and we don't want any title in it. So there we're getting our app bar. Obviously, our screen should be black in color, and we need to change the color of our app bar theme as well. In our app bar, we want only one button here, which is the edit button. And in order to add buttons to the end of the app bar, we need to use the property known as actions. So actions is basically an array of widgets. Inside this, we want a text that's clickable. In Flutter, we have a special widget called the text button. It takes an onPressed, and it takes a child. For the child, we'll pass in the text of edit. We'll put in a comma here again and save that out. As of now, we can't see the edit button here since its color is similar to the color of the app bar. In order to add styles, let's jump into the text button and see if it has a style property. So there we have a style property, and the style property is of type text style. What that means is we can pass in a style property, and the style property needs to be of type text style, and text style is a widget that's available to us. Inside text style, again we have an option of color. So we'll say color. And then Material app already provides us with default colors, which we can access by using colors and then pass in one of the default colors. So let's use colors.white. Again, pass in a comma and save that. And there we see we have our edit button. But like we know in our design, we want this app bar to be black and this screen to be black as well. So let's go ahead and do that. Let's head over to our main.dart, and we can apply a theme to our app directly in our Material app. So here below routes, we'll pass in a property called theme. To know what type theme accepts, let's click through theme, and we see that it needs a widget of type theme data. So let's close that out. Let's pass in theme data, within which what we're interested in is this property called scaffold background color, which is colors.black. There we see our screen has become black. And another property that we need is for the app bar. So if we jump into theme data, let's see if we have anything for app bar. I'm just going to search for app bar, and there we see we have app bar theme, which is of type app bar theme. So let's close that out. Let's pass in app bar theme. We need app bar theme as the type. Inside this, we have a property of color. And again, we'll use the material colors for colors.black. And there we see our header and our screen are both black now. So though this may seem quite alien coming from a React Native background, but theming your Flutter app will be quite intuitive once you start using it. There are tons of options that are available, and they make it fairly simple to theme your app from one particular place. So we set up the scaffold background color to be black and the app bar theme to be black as well. That basically means that we want our app theme to be a dark theme. Now if we head over to the home screen, and inside our container, we pass in a child widget. And then we pass in a text here. Let's call that hello and save that out. You'll notice that we don't get any text here. One option we have is to again copy this style and paste that in here and save that out. And there our text becomes white. But doing that for all our text is going to be quite painful. So let's get rid of this style from here, and instead in our main.dart we have another property known as brightness. Basically, brightness allows you to set the theme of your app. If we jump into brightness, we'll notice that it takes this brightness property, which is basically an enum. If we close this out, back into brightness, we can pass in brightness, and then we can select an option. In our case, we want dark, and then we can save it out. There we can notice by default our text color is white. So there are two main themes available, brightness.light and brightness.dark. If you set it to brightness.dark, it'll assume that your app is a dark theme and it'll make your text white. It also adds certain other changes, which we can see if we disable the scaffold background color and the app bar theme. Let's just comment that out and save our app. We'll notice that it's given our app container a nice dark gray color, and our header is a even slightly darker, close to black color. But since we want the app to be black, we can set those colors here using these two properties. But otherwise, if you just want a dark theme, you can just set the brightness property. So let's just uncomment that for now, so that we get back our black theme, and we also have the properties of brightness.dark, which makes our text white color. Before we start setting up our view, we have to understand how layouts work in Flutter. Basically, there are two main ways of setting up your views, which is by either using rows or columns. Rows is stacking up your views horizontally, and column is stacking up your views vertically. In React Native, we stacked up our views using our flex direction prop. But as you can imagine, in Flutter, since everything is a widget, we probably have separate widgets for rows and columns. So here in our container, let's select this text, press Option Enter on it, and here we'll say wrap with column. As you can see, our text widget has got wrapped with a column widget, and instead of child, now it has this property of children. Children is an array. Basically, that means that it can take multiple widgets. Obviously, we have a column. We want to stack up multiple things, so we need to have an array. So here we have one text. Let's just duplicate this text. Now we have 4 of them. If we save them out, we see we get 4 texts here. I'm just quickly going to increase the size of the text. So here I've just given it a style prop with a text style which has a font size of 30 so that the text is more visible. As of now, we can see that our text widgets are aligned to the start. Let's see how we can change that. So in the column, if you want to see the properties of the column widget, let's click through column. And here we can see we have something known as main axis alignment, main axis size, cross axis alignment, text direction, vertical direction, and text baseline. It looks like main axis alignment is something that might be of use to us. If we have a look at it, it says how the children should be placed along the main axis in a flex layout. So in the background, Flutter is also using the concept of flex to set up your layouts. It's just that it uses this property of main axis alignment to do it. So back in our home screen, in our column widget, let's pass in main axis alignment. Again, it takes a type of main axis alignment. So let's look for main axis alignment. So the properties that we have should look familiar to you. We have start, center, space between, space evenly, and space around, and also end. So here what we're looking for is center for now. Let's save that. And we see that they've vertically been moved to the center. If we move this to end, they'll be moved to the end. If we pass in space between, it equalizes the space between the text widgets. If we space around, it also adds spacing around the first and last widgets. And if we space evenly, it'll give even spacing including before and after the last widget. So all the widgets have equal spacing. This is something that you can play around with to get more used to. So we're just going to leave it at space evenly for now. So that takes care of main axis alignment. In a column widget, the main axis is this vertical axis. So the alignment property will work on the vertical axis. In case we want to handle the alignment on the horizontal axis, we can use the cross-axis alignment. Cross-axis alignment again takes a type of cross-axis alignment. And again, we can see the values that it has: start, center, stretch, baseline, and end. So let's make that center. And we see that nothing really happens. So why does this not work? If we just jump into column and we have a look at cross-axis alignment, we'll notice that the default value is already center. But still we don't see the hello text moving to the center. This is because column as of now doesn't have a width of its own, so it takes up the width of its children. The width of the children text is equal to the length of the text. So if we increase the length of this text here, we'll notice that the text gets longer, so the column gets longer, and then it tries to align its children to the center of the width. We'll be talking more about constraints in a separate video, but for now, to fix this, we can set this to stretch, and then we can align our text to the center by using text align. Then look for the text align property and look for center. And there we see our text moves to the center. Now that we have a fair understanding of how columns work, let's talk about rows. In order to understand this better, I'd like to show you a feature of Android Studio. Here, if you click on Flutter Inspector, it shows you a complete layout of your widget tree. On top here, you have this option of Show Debug Paint. If you click that, it'll show you the boundaries of all the widgets. So if we change this cross-axis alignment and make the center again, you'll notice that the column width has reduced. I'm just going to revert that back to stretch and save that out. So we have 4 texts here that are stacked vertically in a column. It's fairly common to have another widget along with the text widget here. Now let's assume we want to have an icon next to our text widget. Here inside our children, let's pass in an icon. Within the icon we pass in icons, and then we use one of the preset icons that are available with the Material app, and let's just pass in home for now. If we save that, we see that becomes another widget here. Now if you want both the icon and text to be on the same line, let's go ahead and wrap the icon widget into a row. Let's say Option Enter, wrap with row, save that out, and then let's move this text inside the row. So just like a column, a row has children because it can take multiple widgets. It's just that it places these items out horizontally on the horizontal axis. Let's save that, and there we have our text with our icon. Now just like the column widget has main axis and cross-axis alignment, so does the row widget. Within the row widget, let's pass in main axis alignment. Again, the value it will take will be of type main axis alignment. And if we have a look at the values, they're the same values that we had for column. Here, let's pass in center. You'll notice that it's moved its children to the center. But now what if we change the cross-axis alignment of the column back to center? You'll notice something different. Earlier when we put it to center, the items were not being aligned to the center. But once we have a row inside, the columns are getting aligned to the center. That's because if we head into the row widget, we'll notice that it has this property main axis size, and the main axis size is set to max. What that means is, it's going to try and take up all the space that's available to it. So what is the space that's available to it? So the space that's available to the row widget is decided by its parent widget, which is the column. But as we know, the column does not have any width of its own. So the column goes one level above, and the widget above it is the scaffold. So since the scaffold takes up the complete screen width, when we pass in a row, the row stretches to take the complete width as well. If we were to modify the main axis size of the row here, we could say main axis size and set that to a minimum value by using .min. If we save that, we again get back the same issue that we were having with the cross-axis alignment.center. So this brings us to an important point in Flutter. A widget gets its own constraints from its parent. So the parent is the one that tells the widget what is the maximum size it can be. The parent also decides where to set the position of the child on the X and Y axis. The child then tells its parent the size it wants to be within the constraints that were given by the parent. At no cost can the child exceed the constraints provided by the parent widget. So though the row is allowed to take up the complete width, it decides that it wants to take up the minimum size that it can. The row at any cost cannot be bigger than the screen width. So if we were to wrap this column into a container and give that container a width of 100, and here pass in main axis.max, you'll notice that the row cannot take up the whole screen size. It can only take up the size that is provided by its parent widget. So the parent widget, which is the container, is telling the column that you can be a maximum width of 100. The column in turn does not want to be any size, so it takes up the size of its children, which in this case is a row. The row says that I want to be the maximum size I can, but even if I try and be the minimum size, I'm going to overflow, and that's why I'm getting this overflow pixels error over here. So anytime the child widget tries to exceed the constraints that are provided by the parent, you'll get this error. It'll tell you which direction you're overflowing and give you the amount that you're overflowing by. So let's just get rid of width from here and save that out, And also let's get rid of main axis size. This should give you a fair understanding of how to work with rows and columns. Now that we have an understanding of rows and columns, let's go ahead and set up the UI of our home screen. If you just have a quick glance at the UI of the Reminders app that we're building, you'll notice that we have an app bar, which has the edit button, which we have over here on top. Then we have a search bar, which we'll just leave out for now. Then we basically have two main views. One view, which has this categories and lists, and then this bottom portion, which has the new reminder and add list button. So what we'll try and do is, we'll split up our view into two parts, with one part being scrollable and taking these two my lists and categories views, and then we'll create one bottom portion, which is going to be the new reminder and add list buttons. This way I'll also introduce you to a new widget, which is the expanded widget, which you're going to be using very often. So what I'm going to do is I'm going to collapse this column widget and then just delete it out. Save the app, and then we should have a blank screen. Within this, again, I'm going to pass in a child. And like we remember, if you want to put widgets along the vertical axis, we need to use the column widget. So again, we're just going to add the column widget back. Inside this, I'm going to put in children and just create two containers. One will have a color of colors.orange and the other container will have a color of colors.blue. But surprisingly, you notice that we don't get any of these colors. That's because, like we had discussed earlier, the container has not got any constraints from the column, and the column itself is trying to be the size that its children are. So they're actually not taking up any space, and that's why we're not seeing any colors. Instead, if we gave the container a height of say 100, there you'd see the color again. But we want this first container to take up as much space as it can. So what we'll do is, we'll wrap this container with a new widget called expanded. Let's save that. And as you can see, the first container has stretched out to take up the complete space. If we highlight expanded, it says that it creates a widget that expands a child of a row or column so that the child fills the available space along the flex widget's main axis. And if we click through expanded, we'll notice that it takes only one property, which is the flex, and it has to be an integer. It cannot be less than 1, and it cannot be a decimal point. So the expanded widget is similar to adding flex of 1 to a view in React Native. Now by default, expanded already has a property of flex of 1. That's why it takes up the complete space. Let's wrap this container in an expanded widget as well. And here, let's also pass in a flex of 1. And now we notice that it takes up equal space as expected. Then we can just make this 2, and we'll see that it takes 2/3 of the place. So as you can see, the mechanics of flex is exactly the same as it is in React Native. So I'm just going to set this back to where we were, get rid of this expanded from here, and we can just get rid of the flex. And there we have a complete orange screen. In the next video, we'll be adding our two buttons at the bottom, and we'll also be adding some padding around them. Now we've got a container which is of color orange and it's taking up the complete space, but we want this bottom container to have two children, one button on the left and one button on the right. So for that, inside this container, I'm going to pass in a child, and then I'll pass in a row because I want them to be aligned on the horizontal axis, and then I'll pass in children and create two text buttons. I'm just going to leave the on press to null, and in the child, I'm going to pass in a text which says add reminder for the first one. And then I'm just going to add another text button with the on press set to null. And then for the child, I'm going to pass in a text which says add list. Let's save that, and we get the two buttons here. But as you can notice, these buttons are grayed out. That's because when you set the on press to null, by default Flutter will disable those buttons. So instead of setting it to null, I'm just going to pass in rounded brackets and leave the function empty. That way it'll know it has a function, but it won't know that it does nothing. And there we get our two buttons. Now as you remember, we want these buttons to be spread out so that we can have one on the left and one on the right. So for that, we'll do main axis alignment and set the main axis alignment to space between. The buttons look nice, but they need to have some padding around them. The row widget, if you have a look, does not take a padding or style prop, but the container widget does take a padding property. So inside container, we can go ahead and add padding, And here if we highlight padding, we notice that it takes a type of edge insets geometry. So here let's type in edge insets geometry and then pass in a dot and look for a value. Unfortunately, we're not really getting any value that we want. So let's just try and look at the documentation. So if we highlight edge inset geometry, it says that it's actually an abstract class. It's a base class for edge insets. So the right way to use edge insets geometry would be to use the class that extends this abstract class. And that class is known as edge insets. So here it says, to add padding, use edge insets dot the property of the class, or the other way to use it is to use edge insets directional dot then the property of the class. Mostly we're going to be using edge insets directly. So instead of edge insets geometry, let's look for edge insets. And here we can see it's a class that extends edge inset geometry, pass in a dot, and then we have these couple of values. We have 0 to remove the default padding. Then we have all, which will add padding to all four sides. Then we have left, top, right, bottom, which is self-explanatory. Then we have symmetric, in which you can set up the vertical and horizontal paddings. And then we have only, in which you can just pass in one particular direction and pass in the padding. So the one we want here is all, and inside that let's give it a padding of 10. Now if we save that out, we'll notice that the buttons have been nicely spaced from the edges of the container. The last thing here is the add reminder button also has an icon to its left. And actually, there shouldn't be add reminder, there should be new reminder, and that should be add list. So in order to add a button to the left of new reminder, we actually could wrap this text button in another row and then add an icon in front of it. Since Flutter takes care of most of the common use cases, we actually have a specific widget for this very purpose. So just append a dot icon to the text button and you notice it gets a squiggly line. If we highlight that, it says it requires an argument called icon. Instead of taking a child, it takes a label. And for the icon, we can just say icon and then add in an icon that looks like that plus in a circle. So we'll say add underscore circle. Let's save that, and as you can see, we get that icon next to our text. So now it's time to set up this top container view. What we need inside that is a grid which has these 4 containers. So here in our expanded widget, let's get rid of this container widget. And instead, we would need something that would create a grid for us. Normally, we'd look for a list view within which we'll wrap the children to make it look like a grid. But as you can expect, in Flutter, there is already a widget for this. So if we have a look at the documentation, there is a GridView class which creates a scrollable 2D array of widgets. There are basically 3 ways of using this GridView widget. The most commonly used is GridView.count, which creates a layout with a fixed number of tiles in the cross-axis, and the GridView.extent, which creates a layout with tiles that have a maximum cross-axis extent. So what we're looking for is a GridView.count, in which we can specify that we want 2 items in each row, and that will create the grid for us. You can also use GridView.builder if you have a longer list of grids, or if you're not sure of the grid item count and you're loading in items from the web. It'll help improving the performance by loading your grid items on demand. The GridView.builder will also allow you to customize your grid more to create something custom that's not already available in GridView.count or GridView.extent. So let's see how we can use this class. Here, let's look for GridView, and what we want is .count. As we can see, we already get a cross-axis count, which is mandatory. Let's pass in 2 here, and let's just save that out. Let's dive into GridView, and let's have a look at the options available for us. As we can see, there are a ton of options. The ones we're probably interested in are main axis spacing, which will help us space out the grid vertically, cross-axis spacing, which will help us space out the grid horizontally, the child aspect ratio to make the size of the grid item the way we want, and obviously children to actually create the item in the grid view. So let's head back to our home screen, and inside this, the first thing we should add is children. And inside this, let's add a couple of containers. So the first one is going to be a container with a color of colors.blue. I'm just going to duplicate this and give them different colors. And as you can see, we've got 4 containers, and the grid view has stretched out the containers to make sure that only 2 fit in one row. So it's automatically taken up half the screen width. Now obviously, we want this box to be a rectangle. So here, let's set the child aspect ratio, and the normal aspect ratio for rectangle is about 16:9, which will give you a letterbox sort of a look. And there we can see the size is what we want. Next, we want to space out the grid items. So let's give it a cross-axis spacing of 10. That spaces it out horizontally. And let's give it a main axis spacing of 10 as well. And that spaces it out vertically. We also want to have some padding on the sides. So let's add a padding property. And then we need to use edgeinsets.all. And let's give it a padding of 10 as well. And that looks much better. So we've set up our grid layout and we've got 4 grid items. But we know that we want each item to have a rounded border radius. So let's go ahead and try and do that here. In the container, if we want to add a border radius, we need to use a property known as decoration. Basically, if we highlight decoration, it tells us that it's the decoration to paint behind the child. We see that it takes a type of decoration. So let's look for decoration. And if we highlight that, we see that this is an abstract class. And in order to utilize it, we can use box decoration. So instead of decoration, let's pass in box decoration. Open up the rounded brackets. What we're looking for is border radius. So we'll say border radius. If we highlight border radius, it has to be of type border radius geometry. So if we look for border radius geometry, and if we highlight that, we can see that this is an abstract class as well. In order to use it, we need to use the border radius class directly. So here, instead of border radius geometry, we can say border radius. The property that we're looking for is called circular, and the radius we want to pass in is 10. If we save that, we get an error here that says that we cannot provide both a color and a decoration. So what that basically means is, when you pass in this decoration property, you cannot pass in this color property. This is just a shorthand for actually passing in the color inside decoration. So inside box decoration, we can paste in the color, and everything should still work. Now we need to go ahead and change the color of our grid item. So all the grid items have a light gray color. And like we've seen up until now, we've been using the default colors provided by the Material app by using colors dot and searching for the particular color. Let's suppose we want this color to be gray. When we search for gray, we get 2 options, gray and blue gray. If we save that out, we see that we've got that gray color. But what if we want a different shade of gray? As you can see here, when we've highlighted gray, we'll notice that gray has different options. You can pass in a different shade. So here you can pass in square brackets, and suppose you say 100, it'll be a light shade of gray. If you pass in 500, it'll start making it darker. You can make it 700 to make it even more darker, or you can just pass in gray.shade and select the particular shade you want. So this is an easy way of selecting colors that already exist. But what if there is a color that you want that does not match your requirement? Here, if we have a look in our reminders app, we want this particular gray color. I'm just going to use an app to pick out this color, and we notice that we get this hex color. What if you want to use this directly in our app? So here, in order to pass in a hex color, instead of using colors, you can just use color and then pass in the hex value. But you notice that it requires an integer instead of a hex. So in order to convert the hex into an integer, we can just pass in 0x and then pass in the opacity, which we want is 100% for now. So we use FF. If we save that out, you'll notice that we get that nice gray color. So basically there are 3 ways of setting up colors in your Flutter app. The first way is using material colors. In that case, you need to pull in the material.dart file, and then you have access to all the material colors by using colors followed by the default colors. In case you want iOS specific colors, you can pull in the Cupertino class and then access the colors using Cupertino colors followed by the colors that are built into that class. We'll be accessing these colors shortly. And the third way is creating your own custom color, which we just did right now. You can use the hex code to create your custom color. So just like we're done for our first container, I'm going to get rid of these containers and duplicate this first container thrice, so that we get these 4 boxes with rounded corners. What we now want to do is, we want to pass in the data within each of these items. As we know, each of these is a category of to-dos. So we'll go ahead and create a new category class which will help us model our data. So let's open up our project. Inside our lib folder, let's create a new folder. So we'll say new, package, and let's call that models. Within that, we'll create a new class, which is going to be a Dart file, and let's call that category. So the category class will help us model our data for the particular category. And here we'll create a new class called category. Within the class, we want to add some properties for each category. And the properties we're looking for is ID, the name of the category, and whether the category is visible or not by using a isChecked flag. Now, obviously, we need to provide the data types. So the ID is going to be a string, the name is going to be a string as well, and the isChecked property is going to be a boolean. If we highlight this, we can see that we're getting an error here which tells us that non-nullable instance field ID must be initialized. Since we're using a null-safe version of Dart, basically what that means is anytime you provide a variable which has a specific data type, that variable cannot be null. If you expect the variable to be null, you can give a question mark ahead of it, and then you'll see that that error goes away. But in our case, we don't want to do that because we're going to be setting up a constructor. We're not going to be setting up any property values here, but when we call the category class, we'll pass in the values ourselves. See here, I'm going to get rid of the question mark for now, and let's see how we can set up a constructor. So in order to set up a constructor, you use the class name, which is category, and inside this, you can pass in this.id, this.name, and this.isChecked. This here is going to refer to the instance of the class that we use. So now suppose we want to instantiate the category class by saying var category. We'll say category, and within this we have to pass in the ID, name, and isChecked, and we have to make sure we do it in the correct order. So suppose the ID is 1, the name is all, and isChecked is set to true. That's one way of doing it, but that's not very convenient because we need to remember the order in which we need to pass in these particular values. The other way we can do it is by using named parameters. In order to use named parameters, we just need to wrap the parameters in curly braces. As you can see, we are getting an error here, but let's just ignore that for now. Now we can say var category is equal to, let's call category, and you'll notice that inside this, we can actually pass in the ID property and then set its ID to 1. If we want, we can set the second value as isChecked instead of the third and set that to true. And lastly, we can pass in a name and set that to all. So named parameters is a little more intuitive in setting up your class. Now, what is this error that we're getting here? Again, it says that the parameter ID can't have a value of null because of its type. What is its type? The type is string, and therefore it expects a string value. But like we said, we don't want to instantiate anything inside the class, but we want to make sure that when we instantiate the category class, we want to pass in these particular values. So in order to reassure this constructor that we will pass in values, we can pass in a required flag. What this flag will do is it'll tell the constructor that don't worry, right now we don't have values for these particular properties, but when this class is instantiated, the user is going to pass in this particular property. Similarly, we want every category to have a name, so that's going to be required as well. But do we think that we need to pass in this isChecked flag for every category? Let's think of our use case. By default, we would want all categories to be visible. So what we can do is we can actually make this property optional, and then here we can actually pass in true as the default value. Now, within our category constructor, here we don't need to actually set up isChecked, and it doesn't even give us an error because it's not a required parameter. By passing this question mark, we're just telling the type checker that listen, don't throw an error here because I can expect isChecked to not have a value. So to keep things simple, in our app, we're going to mainly be using named parameters when we set up our constructors. We've covered two new data types, which is basically a string and a boolean, and we've also learned how we can make a particular variable nullable. The next video, we'll actually go ahead and set up our categories. So we've set up our category model. Now let's go ahead and set up our categories within our home screen. So here on top, in our home screen, we would normally create an array that can hold the 4 categories, but in Dart, arrays are actually known as lists. So in order to create an array, we have to create a list. So we'll say list, and we want to call that list categories, and then we can create an empty list by using square brackets. So as of now, when we've created a list without a data type, that means that it can take any data type. It can take an integer, it can take a string as well, or it could take an object and so on. However, if we specify our data type here by saying category, which is the model that we had created, let's go ahead and import in category first. You'll notice we get an error here which says that the element type string can't be assigned to the list type category. Now in our array, we can only store types of categories. As you can see, we're getting this squiggly line here as well. That's because our stateless widget cannot have any state that can be modified. So it's telling us that since it's marked as immutable, all the fields that it has should be final. Let's go ahead and mark this as final. And that squiggly line goes away. Basically, when you mark something as final, it means that it cannot be changed. We'll talk about finals and constants later, but for now, this should work. And here within the categories, we'll add our first category. The ID of the category is going to be today, and the name is going to be today as well. I'm just going to duplicate this. The second one is going to be called scheduled, and the name is going to be scheduled. The third one is going to be called all, and the name is going to be all. And the last one is going to be called flagged, with the name of flagged. Now we can come down here where we have our containers, and I'm just going to leave one container and remove the other three. Instead of duplicating the containers, we can now map over the categories and return a container. So inside the children, I'm going to say categories.map. It's going to map over each category, and then using this fat arrow function, we're going to return a container. So I'm going to copy the container and paste it in here instead of null, and get rid of these square braces. As you can see, we're getting an error right now. If we highlight that, it tells us that the argument type iterable container can't be assigned to the parameter type list widget. So this children parameter here expects a list of widgets, but categories.map is returning us an iterable. In order to display our widgets in a list, we need to convert this iterable to a list. In order to convert this categories into a list, we can just append a toList method here. And there our error goes away. If we save the app, we see nothing really changes here because we're still showing the containers. Now inside the containers, we want to display an icon, the title of the category, and the reminder count. So inside the container, we're going to pass in a child prop. I'm just going to close out this sidebar. And in that child prop, we're going to first take a column. A column, as we know, takes children. And the first child is going to be a generic icon since we've not added any icons into our category as of now. So I'm going to say icon, icons.email. Let's save that. And there we see we're getting that email icon. Now we want to pass in the category name. So let's pass in a text, and then we can access category and select its property, which is name. If we save that, we see we get them in a vertical list as expected. I'm going to pass in a comma here to format this out. And now in the column, I want to space them out. So I'm going to use main axis alignment with main axis alignment dot space between. We also want it to be aligned to the start of the container here. So as you remember, we can use cross-axis alignment with cross-axis alignment dot start. Now along with our icon, we also want to show a reminder count. Since we want that to be in the line of the icon, we need to add a row widget. So let's wrap this icon into a row widget, and below the icon, let's pass in a text with a default value of 0 for now. We also want to space these two out. So here we'll pass in main axis alignment, and then we'll say main axis alignment dot space between. We have all three of them in the position we need, but we want to space them out from the edge. And in order to do that, we can add in a padding. A column widget does not have a padding property, but we can wrap it in a widget called padding. That by default adds a padding here, which we can change to 10. And if we save that, we can see that it's starting to look a lot better. In this video, we're going to be talking about variables in Dart. The easiest way to create a variable in Dart is by using the var keyword. So we'll say var, pass in the variable name, and then set its value. As you can see, we haven't passed in a data type to name here, but we can see that the Dart engine has inferred it to be a string by the value we passed in. So basically, the variable name contains a reference to a string object which has a value of Flutter. If we want to be explicit, we can pass in the data type saying string, let's name it another name, and then let's give it a value, say Dart. As you can notice, here we've got null safety enabled. See here, if we create a variable which is an integer, say age, and we try and set its value to null, you'll notice we get an error. It tells us a value of type null can't be assigned to a variable of type int. So that's what null safety brings to us. Before we had null safety, the variable age could take an integer and it could take null. This could cause problems in your code because you'd have to check for null. Now with null safety, when you've declared a data type, it can only take that data type and not a value of null. If you want to have a variable that can take a value of null, you can make it nullable by passing in a question mark. Now it can take an integer and it can also take null. Now there are a couple of important use cases. I'm just going to get rid of these two values from here and I'm going to make this a string. As we discussed, when we want to make a variable nullable, we put in the question mark. And when we don't want it to be nullable, we just remove the question mark and set the value. Now suppose I want string to not be nullable, but here I don't assign it a value. If I highlight name, I can see it's string, but the type checker is not giving me any error. But if I try and print out name, you can see I'm getting an error. It's telling me that the non-nullable local variable name must be assigned before it can be used. The important point here being local variable. So if I set name equal to Flutter here and then print it out, it's not going to cause a problem because this is a local variable and I can assign it later. But what if I were to move this variable out? You'll notice that we're getting an error. It tells me that the non-nullable variable name must be initialized. If I want it to be null, I can pass in a question mark. And then the error goes away. But if I use a non-nullable variable outside of the local scope, it is going to give me an error. But if I use it within the local scope, Flutter is smart enough to not give me an error here and it allows me to use it this way. So basically, when I have a non-nullable variable, I have to initialize it before I use it. But when I move this variable outside my method, if you think about it, you're actually initializing the variable here and then using it, but it still gives you an error. That's because Dart finds it hard to know when you're going to set this variable. But if you're sure that you're going to set it before you use it, you can tell Dart by passing in this keyword called late before the data type. Now Dart knows that you are going to set this variable before you use it, and as you can see, we don't get that error again. So when you're using local variables, you don't need to use late. You can remove late if you want and it'll still work. But when you're using top level variables, you will have to pass in late to let Dart know that you're going to be setting it yourself. So we worked with both nullable and non-nullable variables in Dart, and we've also seen what the late keyword can do by helping us initialize a variable later. But one last thing that we'll cover is how nullable and non-nullable variables work together. So for example, what if this late string here was a nullable variable? We can pass in the question mark and make it nullable. And here inside our main function, we create another variable by saying string, another name. We make sure that we make that non-nullable because we haven't put in the question mark. And now if we try and set this equal to name, let's see what the type checker tells us. It tells us that a value of type nullable string can't be assigned to a variable of type non-nullable string. But as you can see right now, the type checker is giving an issue, but we know that name does have a value. Dart doesn't know that, but there is a way for us telling Dart that listen, I know name is a nullable variable, but I'm sure it has a value and please pass that value into the non-nullable variable another name. And the way to do that is by adding the bang operator or the exclamation mark. So anytime you're sure that a nullable variable actually does have a value and you want to store that value or use that value in a non-nullable variable, you can pass in the bang operator. This will start to make a lot more sense when we start using it in our app. So in the last video, we spoke about variables. Variables are normally used when you expect the value of the particular variable to change. But if you never intend to change a variable, you should try and use a final or a constant. So what is a final? I'm just going to comment this out. A final variable is a variable that can be set only once. So if we say final name equal to Flutter, if we try and change this to anything else, we're going to get an error. We can look at the error. It tells us the final variable name can only be set once. The final keyword can be used with or without the data type being mentioned. The Dart engine is smart enough to infer the data type. So if you wanted, we could also mark this as final string, though we would get the same error. So final should be used when a variable's value does not change, and a constant should also be used when a variable's value does not change. So what is the difference between a final and a constant? The way we set up a constant is quite similar to final. To set up a constant, you use the const keyword. We'll say const string, let's call it another name, and let's call that Dart. Again, if we try and set another name to anything else, say Flutter, it's going to give us an error. If we have a look at the error, it tells us constant variables can't be assigned a value. Whereas for the final variable, it says the final variable name can only be set once. So the minor difference that you'll see here is, suppose in the final, I get rid of Flutter from here. You see that we're not getting an error. Even though we have not initialized final here, we're setting final before we use it. Whereas if you try the same thing in a constant, you'll see we get another error. It tells us that the constant another name must be initialized. So whenever you specify a constant, it has to be initialized. Constants are compile time. They cannot determine their value at runtime. Whereas in case of a final, you don't need to initialize it when you set it up. You can just initialize it before you use it. So for fixed values, which are compile time values, it's better to use a const. Otherwise, you should use a final. It's important to understand that a constant implicitly is actually just a final, with some further restrictions. Now let's talk about another important use case where you'll see the difference between the two of them. I'm just going to comment these two out. Let's say we set up an array or a list, as they call it in Dart. We'll say const bar is equal to an empty list. And similarly, we'll say final foo, which is also equal to an empty list. So here to the final foo, I'm going to try and modify the contents of the list. I can do that by saying foo add and add in a value. And if we try and run it by printing out foo, we should see the value 1 in the array. There we see it. Let's try and do a similar thing for constant. Let's say bar add and let's pass in 1. We're not really seeing an error from the type checker, but let's try and run this. We just get an error saying unsupported operation add. Okay, let's not try and add it. Let's just manually try and update it. So here, instead of adding it, I'm going to say foo is equal to, and then set that to 1. We see we get an error. It tells us that the final variable foo can only be set once. Similarly here for bar, if we try and set it to 1, it tells us constant variables can't be assigned a value. So as you can see for both constants and finals, we can't change the object types. But we can, in the case of final, modify the fields of the object. So as of now, we're passing in the same icon in each category. If you have a look at the completed app, we can notice that each icon is a specific icon with an individual background color. The icons are not straightforward as they have a rounded background as well. So back in our app, what we can do is we can go ahead and create a custom icon. So we'll open up the project folder. Here inside lib, I'm going to create a new folder and call that common. And within that, I'm going to create a new folder called widgets. These are going to be common widgets that we use everywhere in our app. Within that, I'm going to create a new file and call that category icon.dart. Here, let's create a stateless widget and call that category icon. Let's go ahead and import material.dart. And for each category icon, we need to have certain properties that we want to be passed in. The first one is going to be the color. We're going to use it as dynamic because the color could be a material color, could be a Cupertino color, or it could be a custom color that we've created from an integer. So let's call this BG color. And then we want to pass in some data for the icon. We'll set up another final, call that icon data. We'll just decide the data type of this shortly. Then we need to go ahead and set up the constructor. So we'll say category icon. We want this.bg color and this.icon data. Inside our container, I want to pass in a decoration. Call that box decoration. Give it a color of BG color that we'll pass in. Then we want to pass it a shape. And if we highlight shape, it'll tell us that the shape to fill the background color, gradient and image into, and to cast as the box shadow. If this is boxShape.circular, then the border radius is ignored. So that's what we want. We want to set it to boxShape.circle. Then we want to pass in a child, which is going to be the icon itself. If we jump into icon, we can see that this .icon is what we need to pass in. And if we highlight it, its type is icon data. So here we're going to be passing in icon data. And now that we know the type, we can set the type up here by saying icon data. But now we see we get an error for icon data. If we highlight that, it tells us that the parameter icon data can't have a value of null because of its type. Try adding either an explicit non-null default or the required modifier. So basically the icon data that we've specified here is non-nullable because it doesn't have a question mark. Therefore, it's telling us that either provide a default value or make this required. And since we're always going to be passing in an icon when we create the category icon, let's pass in required here. In the case of BG color, we're not getting that error. That's because the dynamic data type can accept a nullable value. However, because we will always be passing in a background color when we create a category icon, it makes sense to mark this as required as well. Now we can go ahead and add some properties to our icon. The first thing we want to do is add a size because we'll always want the category icon to be of a bigger size, say 30. And we're also going to pass in a color for the icon. I always want the color to be a color of white. Let's save that. And now let's head over to our home screen and set up our categories. And here where we are declaring our categories, let's pass in our category icon as well. But for that, we need to jump into category first and declare a category icon property. See here, I'm going to pass in final icon, and the data type we want for it is category icon, which we just created. We need to import that in. So we'll say option enter and import that in here. And as we can see, category constructor is giving us an error. It says add final formal fields. So I'm just going to add that in. Let's just close out the sidebar and pass in a comma here so that it looks better. If you notice over here, what Android Studio did for you was actually pass in this .icon as a non-named parameter. So this is also something you can do. You can mix up non-named and named parameters. So now if you use category, the first parameter should be an icon without this parameter name, and the rest should have parameter names. But since we want to keep it uniform, we're going to pull this in and put it inside our named parameters. And since we've specified category icon as being non-nullable, we have to make sure that we mark this as required here. Now save that out and head back to your home screen. In our home screen, now we're getting an error here for category. I'm going to option enter and add the required argument. Now here I'm going to pass in the category icons. Let's just first put a comma here to space it out. Then here we'll say category icon. The first parameter is a BG color. For this, I'm going to be using Cupertino colors since they match the iOS colors the best. So I'm going to say Cupertino colors, which will make sure that we've imported in Cupertino.dart here. Then the color we want is system blue for the first icon. And the icon itself, which is the icon data, is going to be Cupertino icons dot calendar today. Similarly for scheduled, let's just pass in a comma. And then I'm going to replace null with category icon. The BG color is going to be Cupertino colors, and the color we want is system red. And the icon data is now actually going to be a material icon because I couldn't find one in Cupertino icons. So it's going to be icons.inbox_rounded. Similarly for all, it's going to be category icon. BG color is going to be Cupertino colors. And the color we need is system gray. And the icon we want is actually going to be this one here, icons.inbox_rounded. For scheduled, I'm actually going to use Cupertino icons. And the icon we want is calendar for this. And lastly, for flagged, again, let's pass in category icon. The color we want is going to be Cupertino colors. .active orange, and the icon data that we need is Cupertino icons dot flag underscore fill. Now that we've added our icons to each of our categories, we can come down here where we were displaying the categories. Instead of just passing in icons.email, let's first put a comma here. Let's replace that with category.icon. Let's save that. And there we see we're getting our icon with the rounded borders. We obviously want to space it out from its edge. So let's head back to category icon.dart. Here, let's just add a padding. We'll say edge insets dot all and pass in a value of 5. And that spaces it out nicely from the edges. So we learned how to create our first reusable stateless widget, and that makes it very easy for us to reuse it anywhere in our app. So we've set up our custom category icon, but as of now, we've got all our categories displayed here inside our home screen. It'll be nicer if we can move these into their own file. So here in our project folder, in our models directory, I'm going to create a new file, and I'm going to call that category collection. Within this, I'm going to create a class called category collection. And from our home screen, I'm going to copy out this list of categories. Inside our category collection, I'm going to paste it in. I'm going to pull in category from here, and we'll also pull in category icon. We'll also need the Cupertino and the material classes in order to get the colors in the icons. So you can see in this class, we don't have a custom constructor. We've just passed in a final list of categories which are already initialized, and we just need to access them directly when we initialize our class. Later on, we'll be adding a couple of methods to this class, and then we'll be able to perform some operations on our category list here. Now we can go back to our home screen, and here we'll set up our category collection. So we'll say category collection is equal to, and we'll call the category collection class. Here we'll give it a data type of category collection and save that out. As of now, since we're using a stateless widget, that is, we cannot modify any of the variables that we have inside it, home screen is asking us to mark our fields as final. I'm not going to do that just yet because we will be converting our home screen into a stateful widget shortly. Let's come down here for now, and instead of mapping over the categories, let's map over category collection dot categories and save that out. And as we can see, everything still works. One more thing we can do here is we can actually extract out this particular grid view and move it to its own file to clean this up further. So I'm going to right click on GridView.count, go into refactor, and then select extract Flutter widget. It'll ask me to name the widget. Let's call that grid view items and refactor it. I'll just make this bigger. As you can see, we've got grid view items here. It takes in a property which is the category collection, which we're passing down from the top here. If we go down to grid view items, you can see it's created a stateless widget for us. In that stateless widget, there's only one required property, which is the category collection. And then we have our GridView.count that we had created earlier. What I'm going to do is I'm going to select this class and cut it out. And here within our screens folder, I'm going to create a new folder. First call that home. And inside that home folder, I'll create a new file and call that grid view items. And then we'll paste that class in here. Again, we need to import in material here, and we need to import in category collection. We don't need this key as of now, so we can remove that. We'll talk about keys in the future, and I'm just going to pass in a semicolon there and save it out. Now let's head back to our home screen, and here let's import in grid view items. I'll option enter on grid view items, and as you can see, it can pick up the package already, and let's save that out. And as we can see, everything still works. And now that we have a home folder, we'll select our home screen file and move it into the home folder. Clicking on refactor is going to refactor all the imports for us automatically. Lastly, we'll remove this container which is at the bottom into its own file as well. Let's right click the container, refactor it, extract Flutter widget, and let's call this footer. Since the footer does not take in any parameters as of now, if we come down here, we just have a stateless widget with our footer. I'm going to extract out the footer as well into its own file, which I'll create inside the home folder. So I'll say new file, call that footer.dart, and paste it in here. Again, let's import in material. Back in our home screen, let's import the file in. So now we have our footer, we have our grid view items, and we have our app bar. And everything looks much more cleaner. So here I just have the finished app in front of us. We've already set up the category view. We now need to go ahead and set up the edit button. When we click the edit button, we want the grid view to change to a list view, and then we need to be able to reorder this list view. So up until now, we were using a stateless widget because we had no state that we wanted to manage. But now we want to toggle this edit button to change our view, and that can be done only by using some form of state. Since the stateless widget does not have any state of its own, we need to go ahead and convert this into something that can handle state. So just highlight this stateless widget text and you'll get this bulb icon on the left. Click on this icon and then you get this option to convert to stateful widget. If you click on that, Android Studio will go ahead and convert your stateless widget to a stateful widget. All Android Studio has done is, in order to convert this to a stateful widget, it's created two classes. The first class extends the stateful widget and the second class extends the state. In our stateful widget class, we basically have this create state method which creates the state for the class and links it to the stateful widget. Inside the state class is where we can add our mutable data which will modify our view. Just like a stateless widget, the stateful widget also has a build method. The only difference is that every time the state changes in our app, the framework is going to call this create state method, which will in turn call the build method and rebuild our UI. See here in our state class, we're going to create a string of layout type and set that to grid by default. When this edit button is clicked, we'll update this layout type to list. Obviously the view won't change here for now, but we will alter the edit text depending on what layout is visible. So let's come down here to edit. And in the on pressed, what we're going to do is we're going to check if layout type is equal to grid. Then set layout type equal to list. Else, and we need a semicolon here, else we set the layout type to grid. Also, we'll modify this edit text based on which layout type is visible. So here we'll say if layout type is equal to grid, then show the edit button, otherwise show done. So though we're updating the variable here, if we try and run our app as of now, you will see nothing really happens. That's because we need to wait to actually inform the framework that the state has been updated. And in order to do that, you need to use a specialized setState method. So here, where we're updating the layout type, we'll say setState. It brings up the setState function within which we can actually do our assignment. We can pick this up and paste this inside setState. Similarly, we can put in setState here again, copy out the layout type and paste it in there. If we just have a look at setState, it tells us that it notifies the framework that the internal state of the object has changed. Whenever you change the internal state of a state object, make the change in a function that you pass to setState. So that's what we've done here. The difference here for React and React Native developers is that the provided callback is immediately called synchronously. Unlike React, it does not wait to batch setState calls. It just works right away synchronously. It must not return a future, which is similar to promises. We will talk about this shortly, since then it would be unclear when the state was actually being set. So anytime we want the framework to be notified that I've changed some state and I want it to be displayed here, you need to use the setState method. Now if we click on edit, you notice that it changes to done. Then we click done, you notice that it changes back to edit as expected by this code here. Now let's go ahead and set up our ListView items. So here in my project folder, within the home folder inside screens, I'm going to create a new file and call that ListView items. Since we're going to be reordering our ListView, we'll just start with the stateful widget. So I'm going to say stateful by using stful, and here I'm going to pass in ListView items. Again, let's go ahead and import in material. And just to check that it works, I'm just going to pass in a text here which says ListView. Save that out. Back to our home screen. Here where we were toggling our view and showing the container, I'm going to remove that and instead pull in our ListView items. Let's save that. Let's click on Edit. There we see we get ListView. We click on Done. We're back to GridView. Now here in our ListView items, we'll pass in category collection like we did for our GridView items. Then inside ListView items, we'll instantiate it by saying final. We want a category collection and call that category collection. Then we need to set up the constructor and we're just going to get rid of the key and get rid of the key from here as well. And because we need this, we're going to pass in required here. Now, unlike the GridView items where we were using a GridView builder, here we need to build out a list. So just like most other things, Flutter already has a ListView widget for us. If we come down here, we can see that there are 4 options for constructing a ListView. The default constructor takes an explicit list of children, and then we can display our ListView. If we have a longer list, we can use ListView.builder. If we want to have a separator between our lists, we can use ListView.separated. And for advanced use cases, you can also set up your custom list. Since we only have 4 items that we're always going to show, we'll just use the default ListView constructor. So here we can get rid of this text and instead we'll pass in ListView. The ListView takes a children property. And here, just like we did for our GridView items, we can map over our categories and display our ListView items. So here we'll say category collection dot categories dot map. But it seems like we're getting an error here. If we highlight category collection, it tells us that it's undefined. So when you're using a stateful widget, as you remember, you get 2 classes. One is the stateful widget class and one is the state class. So the data we pass down is actually currently in our stateful widget class. So in order to access this data, we have to actually use the widget keyword. We have to say widget.category collection. If we highlight widget, it tells us a state object's configuration is the corresponding stateful widget instance. So this is going to help us access this data from the stateful widget class. And then we want to map over it by using the .map method. I'm just going to get rid of the square braces from here, put in a comma to format it. Instead of E, we'll make that category. And for each category, we want to pass in a text which has the category.name in it. And we're getting an error here, which is the same error we got last time, that the argument type iterable text can't be assigned to the parameter type list widget. So let's convert this to a list by using toList. Let's save that out, click on edit, and as we can see, we're getting our 4 categories. So as of now, we have a plain text field which is displaying our list items. Let's go ahead and style this a little. In order to style our ListView items, we have a specialized list style widget that's available in Flutter. So I'm going to wrap our text widget within that list style widget. If we highlight list style, we can see that it takes a leading, title, and trailing option. It doesn't have a child property. So let's replace child with title. I'm just going to add a comma here and let's save that out. So our titles are nicely spaced out. Let's just jump into our completed app. We can see that along with our list title, we have the category icon, we have this check mark, and we also have this reorder icon in the end. So we can make the first part leading, the last part trailing, and we can combine the icon and the category name within the title property. Let's head back to our app. Let's go ahead and add our leading check mark. So we'll say leading, then we'll pass in icon and we'll say icons.check. There we can see our check mark. For our trailing, let's go ahead and add icon, icons.reorder. And there we have our reorder icon. Now to give our check mark a background color, we know we can wrap this into a container. Within our container, we can pass in a decoration property. We'll say box decoration. And inside this, we'll give it a color, which is going to be colors.blue accent. We also know how to give it a shape by saying shape and then pass in box shape.circle. And that's starting to look a lot better. Next, along with our title, we want to have the category icon. And when we want to place 2 widgets simultaneously on the same axis, we can wrap it within a row. So for the first child in our row, I'm going to pass in our category.icon. So we've got our icon, but we need to space it out a little from our title. We would normally use a padding to try and space it out, but we're looking for something like a margin here. So since we don't have a widget to which we can add a margin, we can actually use this widget called sized box. We'll say sized box, and if we have a look here, it tells us that it creates a fixed size box. It can take a height and a width, but for now, all we're interested in is a width. And set that to 10. It'll create an empty box for us, which will space out our text from our icon. Lastly, let's go ahead and add a background color to our list style. So let's look for color, and we get this option called tile color, which tells us it defines the background color of the list style when selected is false. So that's exactly what we want. We want tile color, and we want to set that to colors.gray with a shade of 800 for now. And there our tile is starting to take shape. As you can see, we've been adding colors in a lot of places in our app. Soon we'll be creating a custom theme from where we'll import these colors in so that we don't have to add these colors by hand. So we've set up our list view. Now we have to go ahead and reorder our list. In order to reorder our list, we're going to be using this Reorderable ListView widget that's available to us from Flutter. It's basically a list whose items the user can interactively reorder by dragging. It also mentions here that this class is appropriate for views with a small number of children because constructing the list requires doing work for every child that could possibly be displayed in the list view instead of just those that are actually visible. So in our case, this is a perfect fit since we have only 4 items and we should be able to reorder them with no problem. Back in our app here, we're going to change our list view to become a reorderable list view. So we'll say reorderable list view. Obviously, we're going to get an error. It tells us to add the required argument on reorder. So let's add that argument. And for now, on reorder, we'll just print reordered list. One more important thing that now we need to add is the key. So every reorderable list view item must have a key. So here our top level widget is list style. So we're going to add a key to the list style. The way we add a key can be by using this unique key method that's available in Flutter. It tells us that it creates a key that is only equal to itself. So up until now, we were disregarding the key and not using it. A key is useful in such use cases. Here, where we're animating the view or changing the order of particular list items, we want the framework to be able to keep track of those list items. The only way it'll be able to keep track of an item is by identifying that item with this unique key. So let's just go ahead and test out if our reorderable list is working. If we click on the list style, it gets highlighted and we can move it around. Obviously, it doesn't set into the right place because we haven't set up this onReorder method. So inside this method, what I'm going to do is I'm going to print out the old index by saying old index and passing in the old index here. And similarly for the new index, I'm going to pass in new index. Then pass in new index here. As you can see, if we want to display a variable within a string, we can add this $sign in front of it. Let's save that out. Let's run our app. And let's try and reorder our list items. So if we move today from the first position to the last position, let's see what we get here. We get the old index, which is the starting position, as 0, and we get the new index as the ending position, which is 4. But if we think about it, the starting position is 0, scheduled is 1, all is 2, flagged is 3. When we move today from 0 to below the third position, it takes up the 4th index. Similarly, if we move scheduled here from the 1 index to the bottom, it starts from 1, which is the right position, but instead of being 3 at the end, it moves to the 4th position. If we try it the other way around, that is, we move the third item, which is flagged 0, 1, 2, 3, and move it to the 0 position. It starts from the third position and it ends at the 0 position, as expected by us. Similarly, if we move this from position 1 to the 0 position, that seems to work as well. It starts from 1 and it ends at 0. So that means when we're reordering with increasing numbers, we need to take care of the fact that it actually gets positioned at one level higher. But when we're ordering in decreasing order, the starting position is correct and so is the ending position. So this is what we have to take care of in our onReorder method. Let's see how we're going to implement it. Here we'll say if the new index is greater than the old index, We know that the final position is actually one position more than the position it should be at. So we'll say new index and reduce 1 from it by using minus equal to 1. Otherwise, if the new index is less than the old index, we know that it takes up the correct position. So we don't need to do anything. We need to go ahead and remove the item from the old index. So I'm just going to store the item in an item variable. And here I'm going to say widget.categoryCollection.categories.remove at index and pass in the old index. And then we need to go ahead and insert this item at the new index. So we'll say widget.categoryCollection again, .categories.insert, pass in the index, which is the new index, and pass in the element we want to add, which is item. But obviously, for this to take effect in our UI, we need to wrap this into a set state. So we'll say set state, pass in this method inside it, and save it out. Now let's try and reorder our list. So we'll take today from the 0 position, right to the bottom, and we see it sticks there. Let's try and move flagged right to the top, and that works as well. And lastly, let's just try and swap scheduled and all. And that seems to work as well. So as of now, we're directly accessing our categories from our category collection class and carrying out these actions on them. This is not the safest way of doing things. Instead, we should be accessing these methods from our category collection class. So let's head over to category collection and actually make our categories private. We have to understand that in Dart, when we declare something with an underscore, it becomes private to this particular file. It's not particular to this class, which is something you might expect from other object-oriented languages. So if we were to create another class that extends category collection here, we will easily be able to access this category's private variable. However, if we try and access this variable from outside this file, we won't have access to it. So now that we've made this private, we have to have a way of getting this value. For that, Dart provides us with getters. When we don't create a getter, there is a default getter created for us, which allows us to access categories. But now since we marked this with an underscore, we need to set up our own getter. In order to set up your getter, we'll just pass in a list of type category, which is the same as that of categories. And here we'll say get categories and then return our categories. So basically from the looks of it, it makes sense now that we're going to be calling categories, which in turn is going to be returning our private variable categories to us, and we don't have direct access to categories like we were doing earlier. So now if we come back to our ListView items, technically this categories is returning our private categories to us, and this remove at method shouldn't be accessible on it. But if we try and run our app, and we try and reorder our list, you'll notice that everything still works. And we're still working on our original categories. This way, we can easily go ahead and make a mistake of removing any item from the category and it'll reflect in the original categories. A safer way of doing this would be to come to our category collection, and instead of returning the list from our categories getter, we'll return something known as an UnmodifiableListView. So we'll type in UnmodifiableListView, and then we need to wrap our categories into an UnmodifiableListView as well. This particular list view has got nothing to do with the widget list view that we were using to display our categories. If we highlight unmodifiable list view, it'll tell us an unmodifiable list view of another list. Let's see how that's going to help us. If we now try and modify our list, let's try and remove schedule from here and move it down. It looks like it worked, but if we just click anywhere, it just moves back to its original position. If we open up our terminal here, you'll see we get an error. It tells us unsupported operation cannot remove from an unmodifiable list. So basically now we can't just carry out any actions on our list. We have to do it from our category collection class. So this has now made our code a lot more safer. We have to set up certain methods within our category collection, and only those methods will allow us to modify this list. So let's head back to category collection, and here let's set up our two methods. So here we'll say remove item, within which we'll take an index, and only this method can access the private categories, and then we can type remove at and pass in our index. As we know, this is going to return the category for us. So here we'll pass in category as the return type and pass in the return statement here as well. The other method we need to create is insert. We'll pass in the index and we'll pass in the item we want to insert, Then we can say categories dot insert and pass in the index that we've got and the item that we passed in. Since this does not return anything, we'll just pass in void here as the return type. Now if we save that, we have to go back to our ListView items, and instead of accessing methods directly on the categories, we can remove categories from here and call our custom methods, which is remove item and insert. Now if we save that, open up our terminal, try and drag and drop an item, we see that it works perfectly. We can try another category, and there we see that works as well. So by doing this, we've made our code less prone to errors, as we're not directly accessing the categories and calling methods on it. Now the last thing we're left with in our list view is the checkbox. When we tap the list style, we want the checkbox to be toggled. So let's go ahead and set up an onTap method, which is available to us in our list style. We'll say onTap. Within this method, we have to toggle our checkbox. So if we understand this correctly, each checkbox is linked to each category. So the method to toggle the checkbox should actually also be present in the category class. So here within our category class, I'm going to create a new method called toggle checkbox. Within this method, we'll toggle the value of isChecked to the opposite of its value by using not isChecked. Since this function is not going to return anything, we'll pass in a return type of void. Now we can head back to our list view screen. Here in toggle checkbox, let's access the category and call toggle isChecked on that. Based on the value of isChecked, we'll change the appearance of the icon. So let's come down here to the color. Here we'll check if the category dot isChecked is true, then we return blue accent. Otherwise, we'll return a transparent color by saying colors.transparent. Let's save that. Let's try and tap our list style. And obviously it doesn't work because we have to wrap toggle isChecked within a set state. So let's move toggle isChecked inside that. And let's try that again. So now we can see we are being able to toggle the background of the checkbox. We need to do the same for the checkmark icon. And also we'll add a border in case it's unchecked. So here for the icon, we'll just say color. We'll see if category is checked. Then we'll say colors.white. Otherwise, we'll say colors.transparent. So now if we check it, we can see the checkbox is visible. If we uncheck it, we see that the icon disappears. But we want to add a border as well. So here we'll say border. We'll say border.all. Within this, we'll set the color. We'll check if category is checked. Then we'll say colors.blue accent. Otherwise, we'll say colors.gray. And there we see we get an empty circle. If we check it, we see the checkbox. If we uncheck it, we see an empty circle. So visually our checkbox is working, but as of now, if we click on done, we see that we still see all our GridView items here. When we uncheck a list, we want it to be removed from the GridView items as well. In order to do that, let's head over to our category collection class. And here, let's pass in another method which will only return us the categories which are checked. So here we'll say list is going to be of type category. We'll create a getter and we'll say selected categories. Here we're going to return categories dot where to look for a particular category here. For each category, we'll check if the category is checked. If we highlight this, it tells us a value of type iterable category cannot be returned from a function selected categories because it has a return type of list category. If we're familiar with this error, we need to just append toList here and save that out. Now back in our home screen, instead of passing in the category collection, we're just going to pass in the categories, which are going to be category collection dot selected categories. Let's save that inside our GridView items. Let's refactor category collection by right-clicking on it, refactor, and then rename, and let's call that categories. Here we need to change this type to list of categories by saying list category. Let's pull in the category class. And then here we don't need to loop over categories.categories. We can just loop over the categories. Let's save that out. And as you can see, it's already updated. Let's restart the app. Go into edit. Let's uncheck flagged. Click on Done. We see that flag is no longer visible. Click on Edit again. Let's try and reorder the category and uncheck Scheduled. We see Today and All. If we check Scheduled now, we get Scheduled back in the position it should be. So we've created our GridView items and our ListView items, and we can jump between them. It'll be nice to have some nice animation between them instead. It's not surprising that Flutter actually does have a widget that takes care of our particular use case. Whenever we're displaying a view based on a state, we can swap between the two views and Flutter will automatically create an animation for us. So here in our child widget, I'm going to pass in an animated crossfade widget. I'm just going to comment out this code that we had earlier. And for the animated crossfade, let's add in the required parameters. Firstly, we need a duration for the duration of the animation. Then we need the crossfade state, which is going to help us decide which view is shown. And then we'll add the first child. And lastly, we'll add the second child. I'm just going to save that out. So basically we need to set a duration for our animation. The way we do that is by using duration, which is available from the Dart core class. Inside this, we can pass the duration in a number of ways. They can be days, hours, minutes. Obviously, we need a small time frame, so I'm going to use milliseconds, and I'm going to set that to 300. Secondly, the crossfade state is where we're going to pass in our conditional state here to decide whether the first child is shown or the second child is shown. So here, let's pass in layout type, check if it's equal to grid, then we'll select crossfade state dot show first, otherwise we'll say crossfade state dot show second. Next, for the first child, we'll pass in our GridView items. So I'm going to uncomment this and just copy out the GridView items. And for the second child, we'll pass in the ListView items. And let's get rid of the code we had here. All we need is a comma and we're good to go. So everything as of now looks the same, but if you click the edit button, you'll see that we get a nice animation. So everything seems to be working as of now, but if we click on the Run tab, you'll notice we're getting an error. If we have a look at the error, it tells us vertical viewport was given unbounded height. Let's minimize this and let's try and analyze the error. Here we're passing in GridView items, but the GridView items don't have a definite height. Let's wrap the GridView items with a container and let's give it a color of white by saying colors.white, and we can see it tries to take up the whole screen. Instead, we want the GridView items to take up only the amount of space that they need. For that, either we can add a fixed height to the GridView items, or instead, what we can do is we can add this property called shrink-wrap and set that to true. That way, the GridView collapses to take only the height that it requires. If we jump into the ListView items, let's wrap this in a container as well. Let's give it a color of colors.white. And as we can see, it also tries to take up all the space that's available to it. Let's again try and add a shrink-wrap property here and say shrink-wrap to true, but it doesn't really take effect in a reorderable list view. So I'm going to get rid of shrink-wrap. We have to use another way, and that way is by giving it a fixed height. So let's start by giving our list style a fixed height. So here I'm just going to create a constant, call that constant ListView height, and set that equal to 70. We're giving it a decimal 0 to make it a double. Next, let's come down to list style, and here the list style doesn't have a height property. So we need to find another way to give it a height. We've already seen one use of the size box widget, but the sized box widget can also be used to wrap another widget. So let's wrap this in a widget called sized box, and then we can give this a height. The height we'll give it is our ListView height, and let's save that. Obviously, because the size box is now the top level container, we need to move this key out to the top within the sized box, and the error goes away. Now that we have the ListView height, we can give the container a height which is equal to number of items multiplied by the ListView height. So here we'll say height, then we'll access widget.category_collection.categories.length and multiply that by the ListView height. If we save that, everything seems to be working perfectly. Let's open up the Run tab. Let's click on Done. We come back to the grid view. Let's click on Edit. We go back to the list view. Let's try and reorder the list. And it seems to work perfectly. However, it'll be nice if we have some extra height below our list view so that we can see this when it goes below as well. Right now, it gets hidden when we move it below. So what I'm going to do is I'm just going to add an extra list view height here to increase the height of it. Now you can see we have extra space and we can easily move it around. We can now go ahead and get rid of the colors from the list view items and as well as from the grid view items. In fact, the grid view items doesn't even need a container. Let's open our Run tab, click on Edit, click on Done, and everything works perfectly.